Hello and welcome to OpenShift Serverless. Today, part 3, Knative Functions. My name is Ortwin Schneider. I'm working as Technical Marketing Manager in the Hybrid Platforms Business Unit at Red Hat, and my focus is on serverless, service mesh, and creating solution patterns. So Red Hat OpenShift Serverless is an abstraction layer on top of the Red Hat OpenShift container platform that allows developers to start deploying serverless applications in a standardized way. It is based on the Knative open source project, and OpenShift Serverless has three main components, which is Knative Serving. So this component is in charge of deployment and the automatic scaling of your applications. Then there is Knative Eventing, which is an infrastructure for consuming and producing events that drive your applications. And then there is Knative Functions, which we'll have a deeper look at today. So serverless functions are a simpler approach to cloud-native development. You can consider it as the development model and Knative as the deployment model. So with the CLI, if you deploy a function, it will be deployed as a regular Knative service. It has been designed to support the cloud events specifications, so you can connect functions to Knative Eventing components. And this way you can construct event-driven serverless architectures to produce, consume, and route events. It also includes project templates to bootstrap the development project with several runtimes available. There is as well an IDE plugin for VS Code available, and you have different build strategies, as well as the option to build your functions on the cluster by using OpenShift pipelines. So the development lifecycle of OpenShift Serverless Functions normally follow these steps. You start by creating a serverless function project in your runtime of choice. Then you start edit and modify the generated template code. You do your actual implementation of the function. In the next step, you build your function project by using the build subcommand. This will create a container image from your project. In the next step, you are able to test your local container. And then you will push the image to a container image registry. And finally, you will use the deploy subcommand to deploy your container image to the Red Hat OpenShift container platform. In a Knative serving workflow, you would normally have to take care of Knative services like revisions and routes and so on. So in contrast with OpenShift Serverless Functions, the cluster takes care of everything after you deploy the function. In comparison to a standard Knative service, the function comes with a function runtime. So the runtime provides out-of-the-box settings for you. These runtimes normally depend on language-specific frameworks that handle function HTTP invocation process. So this includes also running the actual HTTP server, exposing HTTP endpoints, parsing request data, and so on. With a standard Knative service, you are responsible for what's in your actual container. So for example, the user provides the HTTP server and any additional runtimes. In the next step, let us have a look at the Knative Functions demo. We have an OpenShift 4.10 environment with Knative already installed. You see the three Knative namespaces here. The first thing we do is we create a new project and name it Knative Functions Demo. So here is now our project. Let us directly jump into the project and probably switch to the developer perspective. So there isn't anything in there, of course, because we've just done an empty project. And the next thing we do is we create now a functions project with the name handle GPS, and we want to have a Node.js application with cloud events as invocation type. So we want to handle cloud events. This will create a new functions project, and let us have a look there. So you see this is what's been generated. So we have a Node.js project. This is pretty much a very normal Node.js project. We could also have a look here in the IDE. So here is now this handle GPS folder generated, and we have a package JSON with very few dependencies, just the fast JS runtime and cloud events. Here is our actual implementation of the function. You see it here. So a bunch of comments, and this is our actual function implementation. So there's one handle method, and yeah, probably we want to also add some log outputs here for different data types, and also we want to handle an environment variable to just print it out here, just to show you how you can configure environment variables with the functions CLI. This is where I just implement my normal business logic, and in our case we also return a cloud event as a response. So let us return our environment variable as the payload of the returning cloud event. One interesting part here is there is a func YAML also been generated, and this is basically the configuration of your functions project. So here you have things like what is the runtime you're using, the build strategy, and other configuration options like volumes, environment variables, annotations, and so on. With options, you could also configure the auto-scaling behavior of the Knative service later on. Let us go back, and the first thing we do is we configure now our environment variable. So we have a log of this message environment variable in our code. So let us configure environment variables. Therefore, we could use the func config sub command, and this gives you an interactive prompt where we could now select like what do we want to configure: labels, volumes, environment variables. We want to add a new environment variable in our case, and with a value from a local environment, with a specified value, sorry. So the message, the name is message, and the value is hi from local, for example. So this is now the environment variable configured for our function, and we could also check it here in the func YAML, and you see now here under the envs sections we have now our environment variable configured. So by executing the build subcommand, what we do right now, we build a container image out of this function project locally. So in our case, we use a source to image build locally. This will create our OCI compliant container. And now we have a successful build of our container, and you see also it's tagged with the container registry of my OpenShift cluster. I'm logged in already, and in the next step we want to start this container locally and try to invoke our function with cloud events. So therefore I could use the run subcommand. This will start our locally created container, and we use another terminal window here to invoke our function. So therefore I go in the functions project, and then I could use the func CLI to invoke our function. And you see this is the response we got, our return cloud event with our payload, which is the environment variable. So this way we could now test our function locally. So in the next step, we want to deploy our function to the cluster. But in the cluster, we want to use a config map to read our message environment variable, the value from the config map, and not a fixed value like we have right now. So therefore, we create now config map in the cluster, and now we configure a new environment variable where we say, okay, we want now to get all key value pairs from the config map as environment variables. This is what we select, and now we have the option to select our config map in the current namespace, which was function config. So in the next step, now we want to deploy our function. So the deploy command will again build the function and deploy it. We execute it also in the verbose mode. And now we're using Paketo build packs, so Cloud Native build packs, to build our function and actually push and deploy it in our OpenShift cluster. So our container image has been built, and now we're pushing the function to the container image registry, and now we're waiting for the Knative service to become ready. And that's it. So we have now our function running in the OpenShift, and you see this is a Knative service, this is a revision, we have a Knative route to access our service, and it is also marked as a functions project here. Now let us invoke our function in the cluster. Let us first just start the logs here. So this is the log, and now we invoke our function, and we see here we have the message, the log of our container running there, and also you see the environment variable is high from clusters, so it got the environment variable from our config map. Now in the next section I want to show you how you could use on-cluster builds for your functions. In our case, we've built the actual function locally and pushed and deployed it, but we could definitely build the function with a pipeline in OpenShift, and the way it works is we commit and push our function to a Git repository, and if we then execute the deploy command, this will then clone the function and execute a pipeline in the cluster. And we could adjust the pipeline the way we need if we want to do some static code analysis and all that stuff, right? So therefore we need some pipeline artifacts like a tecton task to build our function. This is what we deploy right now. So there is a func build packs tecton task. Apply this in the cluster. And the other thing is we need a deploy task. Let us check this also in the cluster. If we go back to the admin view, there is a pipeline sections here. If we open this and go to tasks, we should see now our two deploy tasks. This is what we've just deployed. Now in the next step, we need to have a Git project. So we now initialize our project we've created. We commit everything. As initial commit, we rename the master branch, and also specify the remote. But one thing I have to do, I have to actually create now this repository. So that was handle GPS, our functions project. We create a repository now. Go back and push our code. And now before we execute the deploy command, we have to modify one thing. And we go now to the func YAML, and you see there is the build specified to local. This is what we change. So we say, okay, now we want to have a Git-based build. And under the Git section, we specify the URL of our repository and the revision, which was our main revision. So that's all we need to do. And now the function, if we execute a build or a deploy command, this will now trigger a new pipeline in OpenShift. So we execute the deploy, and you see now it's creating a pipeline. This will take a little bit, so a few minutes, because we now have to pull all the container images needed for the pipeline. We could also check this now in the topology view. So if we go to pipelines in OpenShift, you see now there is a pipeline here created through the func deploy command, and it's a very basic pipeline. So we just clone the resources, we execute the build and deploy our function, right? And now we could also modify this pipeline, right? So we could say, okay, edit the pipeline, and just as one example, we could say, okay, now we want, after the build command, we want to add an additional task to, for example, test our pipeline. So we search for an pipelines task, for example, npm. We use this one to execute the test command. So we say, okay, arguments is we want to run npm test, and select the workspace. This is where the sources are. So basically this way we could now adjust our pipeline, use all the tasks we need in our CI/CD process for building the actual function, right? As this takes a moment, in the meantime, what we want to do is we want to handle GPS events. And I have a different project here. Let me show you just what we want to do. There's a project called Bobbycar. And if we go to the topology view, this is a demo environment for a vehicle simulation. So there's a bunch of containers and things running here. Like we have a car simulator. This is the actual component which is simulating vehicles. The vehicles, they are sending telemetry data to MQTT, and from MQTT to a Kafka environment here. Let me show this in the dashboard. So there is a map component of this demo, and you see the markers here. So these are the cars which are simulated, and they're kind of driving here. So we could, for example, select one car and check where is this car currently driving. So we have a cockpit view here, and if I just open kind of the heads-up display, you see this is kind of where the car is driving. We have the telemetry data and so on. And what we are interested in, we want to handle GPS events. For example, we want to handle things like when a car enters a specific zone or something. So all these events that the car emits, so every change of a position, this is something we want to handle with our function, right? So therefore, we want to consume the GPS events which are sent to a Kafka topic. Let's go back to our Knative project, and let's briefly check the pipelines. Oh, okay, you see pipeline has been executed, pipeline run, everything was successful. So that was kind of the cluster build of our pipeline. So now the next step, as mentioned, we create a Kafka broker. So with Knative Eventing, you have different implementation options of the broker. So broker is in Knative API. And in Tech Preview, there is a native Apache Kafka implementation of this broker. This is our broker YAML. So you specify the broker class, which is Kafka in our case. And then we put a reference to the actual configuration of this broker, which is the default in Knative Eventing in our case. Let us create this broker to handle cloud events. Now we should also see it here. Yes, now we have a Kafka based broker. In the next step, we list the topics here. So when we create a Kafka-backed broker, this will create actually in the Kafka cluster one specific topic for this broker with the specified configuration. And we should see now in our Kafka environment that there is a new topic for our newly created broker, and you see it here. This is kind of the topic. What we need is a Kafka source. So we want to read from the Kafka topic where the GPS data is coming in. So this is what we could do in the web console. We create a new event source and use a Kafka source in our case. So we want to consume events from Kafka, select our server. This is our Bobbycar cluster. The topic. So we want to consume GPS events. We need a consumer group, and we want to send our data to our Kafka broker, right? Let's create this one. Now we have a Kafka source running. So this Kafka source will now consume GPS data from the GPS topic and will transform them into cloud events, send them to our example broker. The cloud events will there again be persisted in this Kafka topic of the broker. And now we want to forward these events to our GPS function, right? So here is where we want to kind of implement our GPS handling. So we can drag and drop here and create a trigger. And now we should see in the log files several log outputs for our GPS data, right? So here the logs are running, and you see, okay, there's a bunch of data coming in. Yeah, so you see in the log file, we have all the different events coming in here, like these are the entries, the car ID and the current position, lat long, and the vehicle identification number, and so on. That's basically what I wanted to show you here, how you could use Knative functions also in combination with Knative Eventing to really build your event-driven architectures. And if you want to get started with Knative yourself, you could go to developersredhat.com. There is one link to the OpenShift sandbox. If you follow this link, you can sign up for a 30-day free access to a shared OpenShift environment. And there is Knative already installed. So you could just get started with your own workloads and evaluate Knative serving, functions, eventing. Yeah, so feel free to get started, and see you next time.